Let's look at the IPscan, how it works with network administration. As a network management solution, IPscan provides high technical packet control methods such as ARP monitoring or ARP control, IP blocking or MAC blocking, IP conflict management or IP protection, IPscan with existing DHCP server, built-in secure DHCP server, and 802.1q support in multi-VLAN environment. The IPscan probe uses the ARP protocols to monitor user IPs and MAC addresses in the same broadcast domain in real time. In order to find out the IP and MAC addresses of the PCs in the monitoring range, the probe requests the users in each range for the ARP information. As such, the users who are asked for the ARP information will transfer their IP and MAC information. Then, the probe transfers the information to the IPscan server and saves the information in DB server. Let me explain how IPscan blocks access from a certain user. If a certain PC violates a specific policy, or the administrator blocks a certain user, the IPscan probe is instructed to block access from the user immediately. In other words, if user B changes the IP at his or her discretion, or violates network policy defined, then the probe promptly changes the network address of B, known to all other network devices in the same broadcast domain, which will result in isolation of B from the network. Now, let me talk about the strongest IP conflict detection and protection policy that IPscan features. IPscan checks if the user performs the policy based on the information of all users in the monitoring range. Let's assume that we have user A and user B as in this figure. User B is one who is protected by the IPscan policies. If user A and user B try to access the same network using the same IP, an IP conflict occurs inevitably. If this conflict happens, neither user A nor user B can access the network. IPscan detects this conflict and informs all network devices in the same broadcast domain, for user B's sake, that user B is the first owner of the problem IP. As a result, user A can't access the network while user B regains access to it. IPscan supports both conventional DHCP environment and static IP environment. Currently, the static IP is used for the server or major network equipment. However, only the IP and MAC addresses assigned by the DHCP server are under control. But an integrated management that controls the static IP network devices is not implemented properly. If a proper management of both static and DHCP IP areas is not made, IP redundancy and conflict may occur consequently. Another major issue in security. In the DHCP environment, the users can use the IPs with ease, making it difficult for the administrator to manage the IPs manually. In other words, unauthorized users can access the corporate network and be assigned IPs with no problem, a fatal vulnerability in the network security. Unlike this vulnerability, IPscan detects an access by any unauthorized user right after he or she accesses the corporate network and transfers blocking packets. By these packets, the unauthorized user will be blocked and isolated from the internal network. IPscan is equipped with its own DHCP server and provides a perfect environment for DHCP demanding companies. As mentioned before, major network devices such as the DHCP server that needs to use the static IP can protect important devices from possible IP conflict and use the DHCP reservation function to assign reserved IPs to authorized users. And it also blocks access from a new user such as the guest and assigns a temporary IP range, which this is IPscan's unique feature, can be used only for a specified time period. This will greatly contribute to network protection and management. As IPscan supports the 802.1q trunk port, it can use the port to manage IPs in the applicable range according to the VLAN range. For example, a user in VLAN 3 can communicate with only those users within the VLAN 3 range. IPscan, in the meantime, supports the 802.1q range and manages all users according to the VLAN network. This helps the administrator make the right decision that brings forth an optimal configuration for the entire corporate network.